Open source is catching up. Proprietary models need something entirely new to scale. At first it was throw as much data as we could at the problem. That's our solution. Let's train time compute. Then ChatGPT started to introduce test time compute. Let it just generate more so-called thoughts. Hopefully that will improve the performance. But then DeepSeek came and did the same thing extremely well, making it in the top 5 models, sometimes even first. We have our hammer, and we're continuously looking for a nail to use it on. But it really doesn't make sense when you're using a super expensive piece of product to do something incredibly simple. Sometimes I want a local model. I want a model that's for my specific use case. I want to ask it questions that I don't want to end up at some server that I have no control over. Control is important. The great thing with local models is they are also becoming smaller and smaller, which means they're more and more accessible to your everyday person, up to the point where we have models that can run on your cell phone. Sometimes people think, okay, but we want a model that can do everything, right? Small models are good at very specific things, small things, not difficult things. So they're easy to train, they're cheaper to train, and they will just continue to grow more accurate. I will always see open source catching up to these proprietary models, always. I don't think there's a world where they will never be close.
Today, our guest is Maarten Grudendorst, co-author of Hands-on Large Language Models and an instructor at DeepLearning.AI. Through his open source contributions and popular AI newsletter, Maarten helps make large language models more accessible and understandable for thousands of people. This all in addition to his day job as a data scientist. In this episode, we dive into how AI models have evolved over the last 30 years, when to use open source versus closed source AI models, why small language models could be the future of AI, and the skills you need to stay ahead in the AI era. If you work in AI, data science, or product, or if you're just fascinated by the future of language models, this episode will give you an insider's look at how AI is evolving and where things are headed next. If you enjoy this conversation, subscribe to Data Neighbor on your favorite podcasting app and YouTube. It's the best way to stay updated, and it helps us bring you great content. With that, let's dive into our conversation with Maarten Grudendorst. Welcome back, listeners, to another episode of Data Neighbors with Shravya and me, Sean. We have a really exciting guest today, someone who has helped make large language models more understandable and accessible to many people. We're joined by Maarten Grudendorst. You may recognize him from his fantastic book, Hands-on Large Language Models, co-authored with Jay Alammar, as well as his course on DeepLearning.AI, where he breaks down how transformers work. So Maarten's work's all about kind of making AI more approachable, whether it's through his open source contributions or visual explanations or teaching. Really excited to have you here. Welcome to the show, Maarten.
Thank you for having me. It's amazing to be here.
Welcome, Maarten. We're so excited to talk to you.
We'll get right into it. I really would like to spend our time getting into your background and your recent book. We have a lot of questions around open source versus proprietary AI, representation models versus generative models, pre-training versus fine-tuning, and your thoughts on the future of AI. But maybe just to help set the stage a little bit for our listeners, I wonder if we might start with a little history lesson. AI has progressed really rapidly. And I don't know, for many consumers, like definitely for me a few years ago when ChatGPT came out, it kind of seemed like it came out of nowhere. But in your book, you provide like this really clear timeline of how kind of language models evolved from, say, like even like bag of words to where we are today. So I wonder if you might walk our listeners through kind of that timeline and any key breakthroughs you think that are really important.
Yeah, of course. So for quite a while, the bag of words type of models, those were really popular, right? And they treat it, as the name implies, literally a bag of words, just counting how many times a certain word appears inside of a document. And that's basically it. And the funny thing is, that actually works really well. We're still very focused on embedding techniques and large language models and all that kind of stuff. But even in my day-to-day job, I'm still using bag of words quite frequently because it's small and it's fast and it's still quite accurate. So it's not that we've been stuck with bag of words for a while, but it just works well on doing something a little bit more complex. That's where we need more compute, more data, becomes a little bit more difficult. To me, one of the more interesting things that started to come out were obviously the attention mechanisms that we have with transformers that change the industry. And that's all nice and interesting. But for me, it was actually Word2Vec, which attempted to, convert these words that we have into vector representations. Instead of just one value, how many times a word appears, it now has some sort of contextual information or meaning to that specific entity. And when you have that, when you have a multi-dimensional perspective of a word, to me, that's where things started really rolling. And we started to understand, okay, we have to look at language a little bit differently from, just a bag of words, because it's way more than that. There are many techniques that we find now where we can still say that language sometimes still is a bag of words, depending on the specific use cases. But what we saw is that, this semantic meaning, this context that was missing from a count-based perspective really gives you a whole new field to discover. And that's what I think really started to change the field. And that's what was from a representational perspective, right? Not necessarily the generative part, because what we first had to do was find and create models and architectures that could represent, all of these large textual data, those large corpora really well. So I think that's why there first was a really large focus on these so-called representation models. Models that focus purely on representing the text, and whether that's a bag of words or a vector embedding, doesn't really matter. But the moment you start doing that and you start reaching certain ceilings of performance, that's when you start thinking, okay, well, what if we now take those models and we start generating new text on top of that? And I think that's where we first saw some results, but they weren't really usable yet, especially with GPT-3. It was cool and interesting to create poems, but that's about it. And obviously OpenAI just threw a huge amount of data and money at the problem and made sure it got to that next stage. But that was so costly and so difficult to achieve. That's not something the open source community, I think, could have done.
Yeah, absolutely.
Really cool.
And when you talk about kind of like the vectorization and contextual embeddings, is that what you mentioned in your book when you say like bag of words, like for the word, I think you give the example like the word bank, like you can't tell if it's referring to like a bank where your money's kept or like the bank of a river. But once you have these contextual embeddings, you can start to basically figure that out based on what else is around that. Is that kind of where that took it?
That's exactly the change, right? Because with a bag of words model, the word bank is just counted. And the context isn't really taken into account. A little bit, maybe, but with how many times all the words appears in the same sentence. But the so-called embedding for the word bank is just a count value, where those contextualized embeddings, they really take into account, the other words that appear inside a given sentence or document or paraphrase. And that is truly interesting because, even if you still refer to a financial bank, the way you refer to a financial bank, again, can still differ depending on the context of a sentence. And that's what makes language so interesting, but also so incredibly difficult, because there's a lot of subjectivity inside any given sentence, because quite frankly, it's what we do, right? I speak sentences, I communicate with you, and I try to do that with a bunch of words. But you don't necessarily know the meaning behind what I try to say. So language is inherently really difficult to capture. And the only way to do that, and with those contextualized perspectives, I think, is throwing a lot of high quality data at the problem, where you know that the intention is properly communicated in a sentence or paragraph or what have you, before giving it to the model. Even with a podcast like this, right? You ask me a question, but I might misinterpret it because I don't necessarily understand your intention or your perspective or your view. And that's so incredibly difficult. And the only way, I think, to circumvent something like that from a language modeling perspective is high quality data. And that's, again, when OpenAI started with GPT 3.5 is what they were really good at.
Yeah, it makes me think too. Like I lived in Indonesia for a couple of years, and I took a few months of Bahasa Indonesia when I got there, but even a year in, I'd be living with my host family, and I'd kind of like direct translate. What am I trying to say in English? I'll directly translate it. And my husband, he spoke some English, and he's like, dude, look, I know what you're trying to say right now, but you say it so weird. What you're saying does not actually, like, he only knew because he was like translating it back to English. And then my host's parents were just like, dude, he's like, it's like, but obviously human to machine, that's a totally different thing. It just happens everywhere.
Yeah. And Maarten, in terms of timeline, can you give us kind of like a rough sketch of what we're talking about? Is this like 30 years ago? Is this like very recent? What's the development like for our audience?
So, and that's interesting because something like bag of words, I don't think we exactly know when it was first used. There are some mentions here and there, but indeed we're talking about at least 30 years ago. Because this is so simple, right? Counting the number of words in a sentence. It's a very elegant and cool method to use. And there of course, there are some developments as time goes by, like TF-IDF, where you weigh the importance of words instead of words like the, an, and, an I, which appear in every sentence. It's sometimes meaningless. So small changes, small things that we see growing. But then when Word2Vec came out and we were looking into these sometimes encoder-like models, we started to really understand the power of this technology. And that was like 10 years ago or so. And even that took a little bit of time to be usable by a lot of people, grow in the quality of the data and what we could do with it. So there was also from the community, I think, a huge learning curve to understand, okay, we now use Word2Vec or GloVe or FastText, the kinds of models that can embed these specific words and create a little bit more meaning from it. But it still took 5, 6, 7 years before then transformers became more and more a thing. We focused on BERT-like models, on encoder models, those that really focus on representation of text. And the interesting thing is that's still relatively slow compared, the moment that OpenAI released GPT 3.5, that's when everything went crazy. It was essentially an exponential type of growth.
Yeah.
It felt like. And that was the moment where it was like, whoop, we go with everything we've done in the past 10 years is now done in a couple of months, which is a horrible experience, by the way, to keep up with. But that's what happens.
Everybody's a AI enthusiast overnight.
Yeah, exactly. That's also what makes this field incredibly difficult, because it's so easy for people to get into this field, which is a good thing, definitely. As more and more people easily can get into this field, the competition increases significantly. And I've seen that with a lot of new students that are trying to find work, whilst there are a lot of people that just, they Google some stuff, they ask it, they ask ChatGPT or Claude or DeepSeek, and they learn a little bit, and they can now call themselves AI experts. Information is so close by these days. It's so easy to get. The entire industry changes seemingly overnight. It's a little bit longer than that, of course, but it feels like that.
Did feel like overnight, actually. Hey, Maarten, what got you into LLMs then yourself?
I'm actually a psychologist. So I have master degrees in industrial psychology, so that's more on the work floor, and one in clinical psychology. So that's really focused on helping people with anxiety or depression or PTSD, those kind of disorders, which are very interesting fields by themselves. But I was missing something technical. I still consider myself a little bit of a nerd, and I like statistics. So I then transitioned into data science and did a degree there. But the funny thing is when you transition from a very, let's call it a soft field, into a very technical field, is, at least in my experience, I had to convince a lot of people that I could actually do the technical thing, right? Because a stereotype of a psychologist is that we can't be that technical, right? We're good at this. We're good at talking and understanding people. But when there's an equation, it's like an equation, and it's scary. And I understand where people are coming from, but that makes it difficult for me to then say, okay, but I'm good at what I'm doing. And so I started writing and creating a lot of articles on explaining how certain types of AI work. And it could be, simple things like cross-validation or nested cross-validation to, now at this time in my life, at this point in my life, large language models, mixture of experts, quantization, or more of these so-called advanced techniques. But what I found out is that I really like explaining all of these things to showcase, no, this is how it works and how you can use it. It's where my background as a psychologist really helped to understand how to communicate these things, because the stereotype in a way still is true, because when I started with data science and whenever I did see a very complex mathematical formula, I was like, I don't understand and this is difficult and I don't feel well looking at this. And truly a lot of people have that.
Yeah.
And it makes sense because in a way it's scary, right? What's happening there? It's super complex and you will never be able to understand what's happening, even the most basic of formulas. But that's because it's a language you don't know. So let's focus on the languages we do know, which is just, writing stuff down, visual representations, those kind of things. And you can do that well in the field of large language models. So I really focused a lot in the last couple of years on doing this educational stuff on large language models, on AI. I might want to do also image stuff at some point, but time is limited.
Yeah, I was going to ask you, where do you get all the time? But
I don't know. It's
and you do work a full-time job as well on the side.
almost full time. So
wow.
Yeah, that's difficult. So I work 32 hours on a day-to-day job, which is very cool because we're doing federated machine learning.
Okay.
Which is again kind of different, but very cool technical challenge. And then I have my open source on the side, so BERTopic and KeyBERT and those kind of packages that I maintain. The book then, which even after you're done writing still takes some work here and there, or additional courses or blogs that you write. And of course the blogs, the newsletter that I create, that's fun to do. So also that one. And then miscellaneous stuff in between. So just no sleep. I mean, that's the answer, I guess.
And hopping on to random podcasts to talk about it all too.
Yeah.
That's
to relax a little bit and talk with nice people.
Yeah.
And, yeah, exactly.
Yeah, that's awesome. We're your break, I guess, in between jobs.
Definitely. Oh no, this is fun.
Hey, Maarten, that's so cool. This just came up. If you were to, given how much you've taught people, especially like making things simple is like the hardest thing in the world, right? Like it's never easy to make stuff that everybody understands. It's very easy to make something super hard for people to understand because inherently most things are not that easy. Of all your teaching that you've done, what is your mission for getting people to, like why should people care about LLMs from your perspectives? And I'll tell you a little bit about maybe in a follow-up why this question even came about.
Why LLMs? I don't think that the LLMs there's a hype surrounding LLMs, and to a certain extent, rightfully so, because there is a large impact. I just think it's a cool piece of technology to use. It's as simple as that. If we look at, for the coders that use GitHub Copilot, I'm more of an architect of the code that I'm creating than that I'm actually creating the code myself. Whenever you have a question about certain topics, and large language models aren't perfect, but I can ask it and I can discuss it, and it feels like I have my own personal teacher at times to help me understand certain concepts. And, the principle of having a very smart rubber duck on your desk that tells you, no, that doesn't work, or it does work, or just nudges you towards certain directions is a very interesting and cool experience, because it helps you understand everything so much faster, so much better, as long as you understand how to use it. That's still the difficult part with, forgetful behavior, hallucination, that kind of stuff. There's still risks and there's still things that we have to be careful for. But if you know how to use it, and if you are critical of what's being said, large language models are a truly amazing piece of technology that will enhance lives, but maybe not to the extent where, hundreds of millions of people are losing their jobs.
Yeah, no, that's cool. That's awesome to get that perspective, because where I'm coming from, especially, like we hosted this podcast for a few episodes with many different AI experts in their field, in their own rights, is we've seen people are kind of in two camps. One is like, hey, I'm like this is just another piece of software, so I'm skeptical of it. The other one is like, hey, this is going to change the world. You got to get on board. But it almost feels like there's nothing in between, but then we're like, hey, it's number one, it's real. Number two, it's actually really good to supercharge you in terms of being like a very productive, like just getting you an advantage, especially in the next probably, a year and a half. If you're really good at this, you're going to be really good at whatever else you're doing, whether it's in your job, whether you're trying to get a job, or, just in general building anything. And so, you don't need to be in one camp or the other, but if you're good at using it, just use it a ton, then you're probably in good shape.
Yeah, exactly. And I think that's very similar to my perspective, where it's maybe just an efficiency tool, right? It helps you. It's an assistant helping you out with a lot of small menial tasks that otherwise would be very boring and wouldn't help you do the things that are really productive or really helpful, and just makes your work way more focused on the difficult stuff, the things that relate to your domain experience, your domain knowledge, or your long-term experience of a specific company, or the interactions that you have with stakeholders or managers or colleagues or what have you. And I feel like you don't have to be in one of the two camps. I fully agree. To me, I'm more somewhere in the middle. I understand the technology and I see that it's something very cool. I wouldn't say, okay, everybody's going to be out of a job in X amount of years, or AGI is on our doorstep. I'm not so sure about that, but the impact is huge. I do think it's very difficult to get around something like that. But the interesting part is even though that we expect it to do a lot of stuff and to have a major impact on our lives, it's still difficult to get there. Because so for the last couple of years, the field has moved incredibly fast. But in a way, it's also been very, very slow, because all of this technology, we expect it to be integrated into every piece of our lives by now, right? Because everybody's saying it will change the world and we will do everything. And I think it was a couple of days ago that Apple, was struggling with getting AI properly integrated on their new iPhones. It's the same principle but then you actually need to embed all of this into your software. And that's where it all becomes difficult. It's not a magical tool. Things become magical the moment you integrate it well into software. And that's why something like Cursor, the VS Code alternative, is just an amazing piece of technology, because they implemented this tool incredibly well. And I think that's where the most of the benefit will lie, in properly implementing all of this. And if you can do that well, then you have a killer product. But it takes a bit of effort to get there.
Yeah, we had a guest on this show who does a course on Cursor. When I started looking at that was one of the moments where I was like, oh wow, this can unlock so much stuff for me. I agree. I don't think it's necessarily going to replace a bunch of jobs. I look at more as it makes things for me that before I'm limited by what my skill is and what I know, what I might imagine as a business idea or something else isn't feasible. It kind of opens up just makes your imagination a little more real. Actually, just this weekend, my wife and I were with our niece, who's 7 years old, and my wife, her aunt, has to tell her like lots of stories, and she enjoys it, but like she's making this stuff up. It's hard to make that story up for like 25 minutes. And then this week she had done that for a bit, and she's like, oh, let me like show you like Dolly. What are you imagining? What do you want to see? And my niece is like, how about like cutie-eyed kitty unicorn that shoots rainbows, and then like in the style of Lisa Frank Disney. And it was like, hit it. She was like, whoa, that's so cool. And then they just played that game for probably half an hour. It was awesome because she was imagining the 7-year-old all these crazy, amazing things. And then there's like an image of it. It unlocks what you can imagine a lot easier.
Yeah, and that's really interesting, right? Because especially with skill sets, there are a lot of things that I can't do. But now with these kind of technologies, everything is suddenly possible. And I might not be able to do everything perfect like an expert would, but I can at least try it out and see how far I get. Whether it's amazing story, by the way, super cute. Also showcases the creativity that these types of technologies actually enable, and not necessarily always disable, which is a fear, and a right fear in some cases. But also for me, I have very little front-end experience, for example. But if I now want to code something, a nice demo of some data I've created in HTML, CSS, JavaScript, I let ChatGPT or whatever LLM there is do it all for me. And it doesn't need to be perfect, right? It's a demo. I just need to showcase something cool, something nice, and iterate over it. But now suddenly I can do front end, not in deployment, not perfectly, but I can do it. And there's so many of these cool technologies that are, or skill sets that are suddenly available to you, which wasn't the case before. And that also, for me at least, has been a shift in the way I think about things. Normally, you would think about, okay, this is my skill set, and I'm going to use that, apply that to a specific problem, use case, what have you. And now suddenly there are a lot of skill sets that you don't have, but that you can still apply to the problem just to see how far you can get and just to see if it works. That's incredible.
I mean, one more comment, and we'll move on to another segment of this show, which is like, like one example I like to give to a lot of people is after we talked to Yujung, the other guest that was on the show, who taught a course on AI and how to use it effectively. I then afterwards used Cursor to build a Mario game, like from scratch. I asked it to do it. I had no software engineering background, and it's live on the internet. And I sent the kind of like the link to Sean and Travia like that weekend as well. I'm like, this is crazy. I didn't know anything about this other than just plugging in, and like the possibilities are now suddenly like wide open. And so the 50 startup ideas that I used to have, now they're all become attainable. And that's just because, like, hey, these things actually work. And then after I took your course on deep learning, like I went through the course and stuff, the compounded effect of that is that, hey, you might think of these technologies as something like, hey, it's really complicated, super hard to get to understand, don't know what they're doing. But after that, I'm like, they're pretty straightforward. And then once you understand that, to your point, it's like, hey, they're not going to replace your job, but then you better be like really good at it in terms of, just being comfortable, because if someone else is comfortable and is using it, then you have no chance.
Next, one thing I want to get into is in your book, and also in the course too. In my day-to-day, I'm using OpenAI and I'm using Anthropic a lot. And your book is the first time where I started looking at and learning about some like these open source models out there. And I think you refer to the ones in the book as like GPU poor models that like anyone can kind of run on your laptop or computer if it's good enough. You don't need to have like some massive investment in all these NVIDIA chips. And you've authored and contributed and maintain a lot of open source libraries as well. And I was wondering if you could kind of chat a little bit about like what is open source versus proprietary AI, and why do you think open source AI is important? Maybe what unique benefits it kind of brings to the table beyond proprietary models.
Yeah, of course. So you have closed source and open source models. And for the sake of simplicity, let's start with closed source, which are proprietary models, the OpenAI models, Claude. Wow, I know a lot of open models. No, but those types of models are proprietary and quite frankly, understandably so. They're very costly to train, to develop, to get the right data, to get the right people to create these models. And you pay for them. You pay per tokens, a word or a subword that's being generated or read on the specific service. And so the shift to, this generative domain that we're now in really started with the OpenAI model, proprietary model that did stuff that no one else really could do and did it amazingly well. But the problem is with proprietary models is you have to pay for that, and we don't like to pay for things. But mostly it's a security and privacy perspective. Because, for example, I work day to day in healthcare, and there's no way we're going to send patient data to any cloud provider. We're not going to do that. So then the alternative is something that you can run locally. So that's the open source models, the models that somebody has created and basically said, okay, here you go. You can run it on your own device, on your own hardware. You can turn off the internet and it would still run and do stuff, and you can play around with it. Generally, open source models are less performant than closed source models, and that's kind of obvious because it's something they put a lot of time, money, energy in. So not everybody is going to give it freely out to the entire community, but there are a lot of organizations now doing that more and more and more. And that's because it's becoming easier to train these models and to create them. So we have now a huge amount of open models that perform extremely well. The most well-known is the LLaMA models, of course, with Mixtral and Qwen coming very close to performance and sometimes even exceeding it. And we have seen Exchange crashing with DeepSeek that came out with their own completely fully open model that really nearly outperformed ChatGPT's offering. And that's really exciting to understand then, okay, but sometimes I want a local model. I want a model that's for my specific use case. I want to ask it questions that I don't want to end up at some server that I have no control over.
Right.
That can be just because personal reasons, and whatever that might be is perfectly fine. It can be because your organization doesn't want patient data to end up there. It might be that your organization just has models that they're training, new technologies that they're inventing, and they don't want to share that. Not saying that just because you're using cloud, it ends up in someone else's hands, but that's the concern. You have no control over it, and control is important. And the great thing with local models is they are also becoming smaller and smaller, which means they're more and more accessible to your everyday person, up to the point where we have models that can run on your cell phone, which is very cool, of course. They're not as great as ChatGPT, but they can run. And that's cool because every couple of months, we see that large language models reach a new performance. And whenever they do, the smaller models almost always also increase in performance. So whenever ChatGPT does something amazing, great, because that means good stuff for the rest of the open source community, and typically also vice versa. So to me, when we're talking about open source versus closed source, I don't think one is necessarily better than another. I obviously have a preference for open source, but as long as there's enough of both closed source and open source, I think we have a healthy community of models.
Yeah, so it sounds like it really depends a lot on the use case. Like if a company or a person's evaluating what they want to use, some of those facets of that decision might be around, obviously, like cost is always something to bear in mind. And then it sounds like another big one is kind of privacy and security. Any other kind of dimensions you think someone should be thinking about when they're like evaluating, oh, should I, I'm trying to build this product or something. Should I go with open source versus closed source model?
I also think it has to do with knowledge, because closed source are easy to use. There's a bunch of engineers behind them that have created nice, easy to use UIs and APIs, whatever you need. The moment you're going into open source, that will always mean something you have to hack yourself, that you have to create some sort of software, and it will never ever be as perfect, I think, as the tools surrounding closed source models, which again makes sense. But I think that also is something to take into account. Doesn't mean that it's necessarily difficult to use open source model. It's easy. There are a lot of cool and nice pieces of technologies out there, but because they're often supported by people who are just coding all of these things as a hobby, they might not be the most perfect pieces of technologies out there. And that's not a problem because, again, you're getting stuff for free.
The perpetual trade-off of do you want something easy or do you want something all done for you?
It definitely is, yeah.
Do you think as like AI models in general just become smaller and more efficient, do you think we'll see growth in kind of open models? I'm sure it's going to be going on for a long time. I don't know anything about open source models, but I feel after DeepSeek in the news, at least, people were like, oh, wow. There seemed to be, at least probably not in the open source community, but in the media, for this race to the top by these like big tech companies, and only they can do it by having more and more and more data, and whoever spends the most money on it, and then one of them is going to win, and we'll see what happens to the others. But yeah, I don't know. Now it kind of feels like there's a lot of other options, and maybe there always was, but how do you kind of see it? Things growing in the future.
Is that the ChatGPT moment for open source?
That's a very good point. Yes, it definitely is. But because the moment my parents and my grandparents know about DeepSeek is the moment that it gains the same popularity that ChatGPT has gotten, right? It's in a way still all about marketing and being a household name. Even though, so DeepSeek is an amazing model. It's brilliant, it's very accurate, and they did a huge amount of very cool tricks to make it perform the way it did. But it doesn't mean that there haven't been amazing models, smaller ones, out there for years already. The LLaMA models, the Mixtral models, the Quen models, those are all amazing pieces of technologies that a lot of people, including myself, have been using locally. But what we see now is that as these new models come out, we can use them to train these smaller models through distillation of these very capable LLMs. We can, for example, say, okay, generate for me a poem about blah, blah, blah. And then it does, you feed that through a DeepSeek model. And then that conversation, you can use that as training for a very small model. So the growth of small models will be huge because they're easy to train, they're smaller, they're cheaper to train, and we can generate data using all of these very, very large models. So this distillation process allows us to create very efficient small models. And they will just continue to grow more accurate as we improve architectural performance of these LLMs, but also as we devise more and more cool tricks to use them. Because small models are good at very specific things or small things or not difficult things. And sometimes people think, okay, but we want a model that can do everything, right? But what if you think about LLM agents instead? About LLMs, one bigger LLM that can do a lot of stuff that steers all of these very tiny LLMs to do very specific tasks. Send a mail, summarize this, transcribe this, and then aggregate all of that information into the larger model where it can be processed. So these small models are very good at expanding the potential of these larger models, I think. And especially as we see that with, for example, Cursor, where you can use agents to create files and to look up code, to do all of that stuff. You don't want a very big model to do very basic things. But if we have a very small model that's still like 90% as accurate, the larger model can still steer that model into very specific tasks. And that's the agent perspective. Small models are amazing to use on your phone or as a Siri-like assistant, all kinds of purposes. Use it in your browser, for example, to summarize information on a given page. You don't need DeepSeek-like levels to do basic summarization of things. So these small models, I think that's what makes it possible to use them across all of the technology in your life, if it makes sense.
When you think about, you made a point there around having specific tasks that just got me thinking. So would that be another benefit of open source, for instance, is it easier to say, like, tune those models to a very specific use case that you have within your product that you might not be able to do with a closed sourced model? Or maybe even to get into, like, could you talk a little bit about kind of what pre-training is versus fine tuning, and then where there's kind of like an opportunity for people to get their models to do like more specific tasks?
Yeah, so you make an excellent point, right? So we talked about security and privacy and things like that, but fine-tuning for very specific tasks, this also becomes easier and easier. So we generally it's rather black and white because technology changes and things change, but there's a two-way approach to creating these large language models. And the first step is pre-training. And that typically is the most costly process, where we have billions of documents that we just throw at the large language model and say, okay, learn to predict the next word, and that's it. Nothing more. And in a way, it's in order to, quote unquote, understand these documents and understand language and understand reasoning, understand the way people talk, all those types of things. So to get a basic foundation of the world, so to say.
Gotcha.
And
this is really expensive to do.
Yeah, really, really expensive. That's where most of the money goes into. And when you have that base model, typically it really can't do much more than just predict the next word. So it doesn't have to be a conversational model yet, because it might not have been trained as such. And then fine-tuning involves training it to a very specific task. But the task can also be conversation, to make sure whenever I ask a question, the model gives an answer that I'm satisfied with. And there are many tricks to make sure that process works well, but that's a task. And after you have done that, you have your conversational model that people generally use. Those are the instruct models or the chat models. And then you can even do another round of fine-tuning after that with very specific domain data, because there's a lot of data that's not available to entities like OpenAI or Anthropic or what have you. For me, for example, I work in a cancer research institute. We have a lot of very specific domain data that many of these models struggle with. To answer your question, open models allows us to then fine-tune these models on that very specific data. We know that the data is not going to end up in strange places. We have control over it, and we have our own model that has, learned some of this domain knowledge and can reason a little bit better about our specific domain.
Yeah, that makes a lot of sense.
Really cool.
So we'll add that to our dimensions of when to evaluate, which to use, open or close. You have kind of the cost, your kind of like knowledge and comfort with working with those models. You have privacy and security, and then you also have, do you want something to be more specific around the domain you're working on, where that one of these larger models might not have.
Yeah, and there are a couple of other nuances that you can even include, like if you're using proprietary model, you never know, or you don't necessarily always know which model you're using, if it's an updated version, older version, if they add a lot of business rules between the model and the actual output. So a lot of constraints that you might not want to have. There's a lot of focus on uncensored models. For example, if you're writing a horror book and you want some inspiration about how to phrase certain types of things, I believe ChatGPT in its early days would say, no, I'm not going to generate that kind of content because it's potentially hurtful. And that makes sense. But for very specific use cases, that might be difficult. So you might want to use an open model that maybe doesn't have those downsides. So it's much of it really is about control over the model.
Yeah, absolutely. I mean, if OpenAI goes down, your product goes down. Whereas, sure, exactly. that same thing will happen if your own like locally hosted model goes down too, but at least you have control over that, and you're not just on X tweeting at OpenAI like, come on, get on there. It went down the other day actually. I went on, I don't really usually go on X that much, but I was like, is it down? Like, what is going on? I was just trying to do some stuff in Cursor, but it was quite funny actually. There was a lot of students who were like, I have a test tomorrow. Like, this paper is due. Like, I'm gonna get an F. I was like, oh man, that external lack of control.
Oh, that's amazing.
It's hard.
Just use another model. There's so many out there.
Exactly.
Currently.
Exactly.
What's your prediction, Maarten, in terms of the proliferation of open source versus closed models? Like, I'm thinking, like in the business side, kind of like, hey, what's the market share of the two? But like, do you feel like one is going to be more dominant over time? I'm guessing like one is probably a long tail over the other.
It's a difficult question because obviously I don't know all of what's happening in the proprietary side of things. I know some, but not enough to give a full picture. That said, the trend thus far has been that open source is catching up and that they're growing closer and closer to one another, and that proprietary models are still doing very cool stuff, but that it sometimes seems like we need something entirely new to scale, right? So at first it was just throw as much data as we could at the problem, and that's our solution. That's called train time compute. Where we focus on training the model. And then ChatGPT started to introduce test time compute, where you focus on the output of the model. So give it more time to generate tokens. Let it just generate more so-called thoughts. And hopefully that will improve the performance of these kinds of models. So that was the trend. But then DeepSeek came and did the same thing extremely well, making it, in the top 5 models, of which the other 4 were proprietary. And I think depending on the evaluation metric, it was second, sometimes even first. So you can say that many of these models are catching up. That said, there's a lot of new technologies being developed that have shown tremendous potential that, if implemented well, could exceed some of the models that are currently out there. And I think that's something for the proprietary side of things to do, because it's crazy expensive to train these models. And if there's a new type of technology out there, whether it's Mamba or BitNet or all different types of architectures that these large language models have, a university is not going to train or gonna just throw 50 million at the problem and see whether this architecture actually scales to that size.
Right.
That requires a lot of testing to see whether that all works out. So it's very difficult to say which of these pieces of technologies is going to be the next thing. I think Google recently released a new paper, Google Titans, which is supposed to be, again, an improvement on the well-known transformer architecture. But again, there's so many of these papers that really do show tremendous potential. Just the implementation and scaling it then to the size of these DeepSeek-like models, that's expensive. But quite frankly, I will always see open source catching up to these proprietary models. Always. I don't think there's a world where they will never be close.
Yeah, that makes sense. What recommendation would you have for our audience, viewers, listeners who maybe are like, hey, you guys are recommending me to get into AI and just be comfortable with it, but there's so many options. Like, what do I do here? I'm lost. What's my step one?
First, you got to get his book, hands-on large language models, I've got it right here.
And go to the
one
course.
recommendation
That's
right
nice
there.
Of you. No, the very, very first step would be to go to ChatGPT or Mistral or Claude or whatever platform that you know and try it out. The example, Sean, you gave about the DALL-E with your, was it 7-year-old cousin? That's cool, right? Do something that makes you excited using this type of technology. Don't use it for the sake of using it, because that becomes boring. It still needs to be a nice and interesting, a cool learning experience. But yes, there are still so many things to do with it. But I don't think there's necessarily a wrong way to start interacting with these models, because it's a new technology. It's still new. It's not that old. We believe it will change the world. It's the new internet, so to say. But that means that because it's new, it will change in a couple of months with some new technology that comes out. So just being familiar with interacting with an LLM, asking it tough questions, easy questions, fun questions, to get a feeling of what these types of technologies can do, but also what they cannot do. Because I can tell you what they can and cannot do, but that lesson will work much, much better if you just do it yourself.
I think there's one really like an understatement that you just highlighted there, which is like use it for something that you like, as in like just try it out in your daily life, integrate it seamlessly instead of I have to use it, so I need to write it a prompt. One just inspires you much more than the other once you see the same results, probably. So I love that.
What are you already doing? It's not like don't go in there and be like, what can this do? Be like, what am I already doing? Can it do that? Things you already know about. Like with my wife and my niece, like, oh, I'm telling this story. Like, I'm really enjoying it, but it does require a lot of kind of like creativity. Is there something that can supplement that? Or obviously in your work too, it's like, I don't know. I've done this analysis, and now I have to summarize it in a way where a non-technical audience can also understand it before you might spend a lot of time on that. Try leveraging one of these models to do that instead.
Yeah, and that's the thing, right? With this hustle culture that we live in currently, people like to focus, everything that I do should be useful and should have an output that people can use, or that I can use, or that I learn from. That's nonsense. That's not a way of living, I think. Do what's fun. And if usefulness is fun to you, then do usefulness. But if you just want to create a Super Mario game, because that's cool to do, then do that. If you want to create images, see what's possible. If you want to create a storybook for your daughter or your son to read, that's also cool to do. It doesn't have to be the most useful thing out there. I think the best learning experience that you can ever have, if you're motivated in an internal way to do it and to learn all of this new stuff. And fortunately, I have been, so that's nice. Not everyone else is, and that also makes sense. But I would always say just focus on the fun things. And if you do that, then easy learning is by far the most easiest thing there ever is.
I think we got our punchline for this episode.
Yeah, I really want to create a storybook for I've been thinking about a storybook for my wife for her birthday. That's about our dog. So cool. This will be the Easter egg in the episode. We'll see if she actually listens to this. if she's gotten this far, she'll know where her birthday present is. But
Do
I
that.
don't
That's
know.
that's
Let's
a
test.
very cool experience to
That'd be
create
cool.
something like that.
Yeah. So we're almost at time here. One more topic I wanted to discuss though before we go is we've been talking a lot about like these new models or these like generative models. Something that I was just thinking about, you mentioned how, hey, maybe sometimes small models are better than large models, depending on their use cases. What use cases would you say that like pre-existing representative models are still better at than like a generative model? Like an example I was thinking of the other day in my own work is like, okay, like I have these documents or clauses or something, and I want to classify them. I probably don't need to jump straight to like hitting OpenAI's API to like classify this stuff. There's probably pre-existing things like BERT that I can use for that. Maybe some of the use cases comparing those two.
Yeah, so the most common use case for representation models, I think, currently is to use embeddings, those vector representations for, let's say, sentences or paragraphs, because they're very relatively cheap to generate compared to a given generative model. And then you have a representation for your entire data. Let's say you have 10 million documents about whatever subject. You only have to generate all of those embeddings once. You store them somewhere in a database, and you can access them whenever you want. You don't have to recreate these representations, and you can use those to train a model for classification, or in my case with BERTopic, which is a topic modeling package. It models the most frequent topics in those 10 million documents. And the alternative would be to use a generative model, let's say ChatGPT, to go through those 10 million documents one at a time and, for example, extract the topics or to classify something. A, super expensive. And B, what if I want to change the prompt and run it again just to see if I can now do it better? Then it will be again super expensive and quite slow, because 10 million documents through ChatGPT, that's not going to be fast. And that's what we typically see between those things. Is it feels like we have generative models, we have our hammer, and we're continuously looking for to use it on. But it really, really doesn't make sense when you're using a super expensive piece of product to do something incredibly simple. And with embeddings, you can get away, not even get away, it's still very accurate, those representation models, but you can do all of these types of analyses, create classification models that are cheap, that can run in production with low latency, little cost, to classify spam or what have you. We're not going to use, GPT reasoning models to classify spam. It's a complete waste of resources. But those representation models, what they do well is they give you that representation, those vector embeddings, and you can store them. And that storage is very interesting because it allows you to create some sort of database for your input. Let's say, again, those 10 million documents. And then you can throw a generative model on top of that and say, okay, I have a question. And we search in that database between those 10 million documents to find the most relevant one and feed those to the generative model. We only use the generative model for more difficult tasks because, it's focused on generative AI, not necessarily classification. Instead of always focusing on those big, large, generative DeepSeek-like models, those embedding models don't just have their use cases. They're still extremely popular for retrieval tasks, for clustering, for classification, just representation, semantic deduplication of data. Let's say you have 10 million documents and you want to deduplicate them. You're not going to use a large language model for that. At least the generative model, representation model is way more efficient. So there are hundreds of use cases where you would rather use an embedding model than a generative model. And I do feel like that people tend to forget that.
Yeah, the latest, greatest, and shiniest object always wins, right?
Yeah. And it kind of makes sense, right? Because it is really shiny.
Yeah.
It is very cool. It does very nice and amazing things. But what happens is that new generation of data scientists or AI people will focus on those generative models and keep forgetting that embedding models exist, that you can train a very cheap BERT model for classification tasks and not cost your company many thousands to keep it live.
Yeah. It almost reminds me a little bit of like in data science and ML when sometimes people will jump to like more complex models like, I don't know, XGBoost or something. And then it's like, oh, dude, you can just use regression for that. Like, we're not trying to do anything too crazy. It's super quick and like, it just depends on the use case, really.
And that's really fun that you mentioned that, because that has always been the case. When Word2Vec became a thing, people would say, no, just try bag of words first. And then when more complex embeddings became a thing, people would say, no, just try Word2Vec or again, a bag of words first. And we continue on this trend of saying to always focus on the shiny new thing, but know that there's dozens of years of very cool technologies that are way cheaper, efficient, and sometimes even more accurate than those new shiny models. So it's nice to see this trend happening over and over and over.
Yeah. Hi, any other questions from you?
No, I think that's been such a wonderful conversation, Maarten. Yeah, nothing from on my end. I think we can close it out.
Yeah, one more quick question I like to ask everyone in terms of like whether someone's maybe in the field of data, since you're a data scientist or also ML or AI. What do you think is the most underrated skill someone may want to invest in as they're breaking into or progressing in the field?
A little bit biased as a psychologist, so you know where this answer is going. But I do think it holds true, as objective as I can be, is truly communication. In most cases, you will always be interacting with people and not necessarily systems. The thing that you're deploying, that you're making, is going to be integrated within an organization that's comprised of people, stakeholders that don't really care sometimes about the performance of your model. They just want it to be useful. So you have to explain why it is useful for them and how it can help the organization. And that's not because you fine-tuned a large language model and that's very cool. No, it helps the business case because of X, Y, Z. And this communication part, I think, is one of the more complex things that you can learn. Because how do you communicate well? There's not a guide somewhere that tells you the exact steps that you have to do every single time, because people that you communicate are all different from one another. The context is entirely different. So it's a feeling in a way that you develop by doing it more and more and more. Now, the good thing is that teaching in a way becomes more accessible with something like TikTok, for example. Just record yourself, explain something in 30 to 60 seconds, put it online. That's step one. Do that plenty enough of times and you can really learn to understand what people want to see, when people will listen to you, when you explain something clearly enough that the questions people ask are not about, okay, I don't understand it, but how then does also this and this work? And how would you integrate this and this into your technology or whatever it is? So communication just I think is what makes the world work and will be. But in data science, it's especially useful because I've seen so many organizations that have data science teams, but still have to explain to business why they exist and why they're useful and why they should remain existing. Because they're often not a product, but consultancy or advisory or what have you. And the only way you do that is through communication.
Wow, that was so good. I think the takeaway there, Maarten, is everybody should learn TikTok. That's the most underrated skill.
I'm okay with that. Not too much.
No, but that's really good though. Like, I can't agree more. It's like of all the really interesting, really cool technology, especially AI frontier stuff, like it always comes down to the basics, right? Like what's valued the most never changes. Not in the face of this like really cool technology. It's still going to be how you interact, how effective you can be, and how much impact you can land in whatever you're doing.
Yeah. Well, great. We won't take more of your time, Maarten. I know you're a very busy person with all the different things you're juggling, but thank you so much for coming on the show. I think our audience is really going to enjoy this one. Lots of great conversation and learning here. To our audience, if you enjoy this, please like and subscribe, drop a comment, and if you have other questions for us or Maarten. I also wanted to plug again, check out Maarten and Jay's book, Hands on Large Language Models. Check out the Deep Learning AI course they did on how transformer LLMs work. Yeah, for me, those are super helpful. So also just thank you for writing, and going to keep following your stuff along as well.
Oh, that's kind of you to say. It was a truly a blast to be here and have these kinds of conversations.
Love all the work that you've done, Maarten. Please keep it up because I'll be sure to be following.
Great.
Thank you. I definitely have some things in the pipeline, which hopefully 1 or 2 weeks, maybe a new visual guide. That would be cool.
All right, we may have to have you back on the show sometime in the future to check that stuff out. But yeah, thanks so much, everyone. We'll see you next time.
Thanks, everybody.
Thanks.